So hello everyone and welcome to the Phosphate Digital Week. To present myself quickly, I'm Justine Martini, Junior Product Manager here at Phosphate, and I will be the animator of this session. So today we are excited to present a crucial topic in aquaculture, enhancing skeletal mineralization and water quality, the role of phosphates. This webinar series addresses key challenges in livestock farming, including aquaculture, poultry, swine, and ruminants. In this session, we will explore the vital role of phosphates in improving the skeletal mineralization of fish and shrimp, as well as enhancing water quality. Our guest speaker, Dr. Wolfgang Kopp, owner of Simplify Fish, will share his expertise in fish nutrition and physiology. Dr. Kopp, who earned his PhD in 1993, and has led significant research in aquaculture nutrition, will provide valuable insights during his 30-minute presentation. After that, our aquaculture product manager, Guillaume Morin, will discuss phosphate solution with a particular focus on MSP during 15 minutes. And finally, we will conclude with a 10-minute Q&A session, giving you the opportunity to ask all your questions in the dedicated chat room. So to access to the chat room, you need to click to this icon. Thank you for joining us, and we hope you find this webinar both informative and engaging. And now, Doctor, you can share your presentation. Perfect.
Okay, let me go back to the presentation. Hello, everybody. Good day. Welcome to the aqua part of this web seminar. Thank you for the introduction. Feed phosphates in aqua have been accompanying me since I started with fish feed 30 years ago. A lot has improved since we started with it, and there are many possibilities today to find nutritional solutions that are related to feed phosphates in fish feed and in shrimp feed. What I would like to do today is actually to share with you my experience on the effect of feed phosphates on the fish and on the environment it lives in. Phosphorus, for me, is a very central, if not the central nutrient in the aquatic system. Mineral deposits today actually are representing the largest amount of phosphate or phosphorus which is present in the world. Most of it is used for plant fertilization, and a lot goes actually into animal feed. When you work in the aquatic environment, when you work with water, you actually find out that phosphorus there plays a different role from the other ecosystems. We know that phosphorus is a deficient nutrient on the global scale, but it is also extremely deficient in aquatic environments. The phosphorus concentration in freshwater is extremely low, only 0.03 milligrams phosphorus per liter. This is an extremely low concentration in relation to the demand, the requirement of the organisms that live in it. So actually what it does, it limits the growth of aquatic plants, since it is the first limiting nutrient. Through this, it actually decides on the biomass or the production capacity of water bodies. So from an ecological perspective, we see phosphorus as one of the most important nutrients. in a good sense, that it is able to enhance biological production, but also potentially in a negative sense that an oversupply can lead to problems with an overproduction of organic matter. I will come back to that in a moment when talking about the right amount of phosphorus to be added to aquafeeds. So when talking about, sorry, let me just, yeah. When talking about phosphorus in aquafeed, we first need to see how much of the phosphorus can the fish actually take up from the environment. We know, for example, for calcium, that fish which live in water, which is full of calcium ions, can perfectly cover a lot of their demand, if not 100% of their nutritional demand, through the absorption of calcium from water. However, since phosphorus is very low in water, I showed you the concentration on the previous slide, both fish and shrimp actually need a dietary phosphorus supply. For a long time, it was believed that fish were not able to absorb phosphorus from water, that they lack actually the pumping system to do this. However, this is not true. Fish are very well capable of absorbing phosphorus from water. I show you here a slide or a cutout of a presentation which was done on European catfish, a study which showed very clearly that when fish, in this case the catfish, were deficient or were slightly undersupplied in phosphorus, they were very capable of absorbing phosphorus from water. However, this was only possible at very high phosphorus concentrations. If you look at the legend of this graph, you see that we added phosphorus up to levels of 100 milligram phosphorus per liter, which is many-fold more than occurs in a natural water. So the reason that fish seemingly could not absorb phosphorus from water was only that there has never been enough phosphorus in water. Under normal culture conditions, phosphorus levels are low in the water, and most of the phosphorus needs to come from dietary supply. However, today we have some production systems like recirculation systems, and we do have pond culture, especially in some species on another trophic scale, for example, shrimp or carp, where phosphorus is accumulating to very high levels. So there, the phosphorus supply from water can play an important role. When adding phosphorus to the diet, of course, you first need to understand where does the phosphorus come from. And we can clearly group three different origins of phosphorus for feed. We have on number one, the animal protein sources. The animal protein sources can be sea-based or marine-based or land-sourced. When we talk about marine protein sources, mainly it is fish meal, which is in question here. And when we talk about land-sourced animal proteins, we're talking about poultry byproduct meal, we're talking about feather meal, and we're talking about hemoglobin meal. Very important to understand what is the contribution or how is the contribution of the phosphorus of these protein sources shaped. It actually stems from two sources. It is bone, so mineral phosphorus, which is supplied a lot, and it is the second part, which is coming from the soft tissues, call it the metabolically active or easily soluble phosphorus. This is important to keep in mind to understand the bioavailability of the phosphorus, because it is very different if it comes from a bone matrix or if it comes from a soft tissue matrix. The second phosphorus source in crude terms are the plant protein sources. Plant proteins do actually also have a twofold type of phosphorus origin. One is the storage form of phosphorus, which is phytate in plants. Well, we all know that phytate is, or the phosphorus from phytate is not bioavailable to vertebrates, though it can be hydrolyzed by microorganisms or by the addition of phytase, which I will talk about in a moment. The second part, which is only a minority, it is estimated to be between 20 and 30%, is again the metabolically active phosphate, which is very similar to the, or partly similar to the animal protein sources coming from ATP, for example, or from phospholipids. Again, very important here to know the origin and to understand the bioavailability. And the third part, which actually is very important to steer the dietary phosphorus to the level where we want it to be, are the mineral phosphorus supplements. Here we have, just to name a couple of substances, the dicalcium phosphate, monocalcium phosphate, monosodium phosphate, which we all know about. Important for these are, they have the advantage of being chemically defined and also the advantage of being possible to standardize. So we can actually standardize the chemical composition just by the selection of the type of pea supplement, which element we want it to be bound to. And second, also by the physical treatment. So we can actually treat it in a way that it maximizes the bioavailability. And that leads to a very standardized quality, also not only in terms of chemical composition, but also in terms of bioavailability. So overall, talking about phosphorus availability, we find the most consistent phosphorus availability in mineral phosphorus supplements. We can expect a very low phosphorus availability from plant sources, since the majority is present in the form of phytate-bound phosphorus. And we have to expect a very variable phosphorus availability for fish meals and poultry meals and similar products, since the bioavailability depends on the composition of the raw material. And this can vary a lot depending on the type of rendering that has been applied, or also when looking at fish meals, very much related to the origin, the type, the species of fish actually being caught for the fish meal production. So there needs to be a lot of focus on variability here. And that's what I would like to stress also for the further discussion on mineral supplements and the role they play in this game. I mentioned already when talking about the plant sources that the majority of phosphorus in plant sources is bound in phytate or phytic acid. Phytic acid is not available, or phosphorus from phytic acid is not available to monogastrics. It needs bacteria to split off the phosphates from the inositol ring. So it's a hexainositol phosphate with 6 phosphorus atoms on the inositol ring. And this is a job that animal enzymes or monogastric enzymes cannot do. Therefore, in pig and poultry feed, it's very, very common these days to add supplemental phytase to increase the phosphorus availability from plant feedstuffs as a supplementary action actually to meet the bioavailable phosphorus demands. In aquafeed, there are phytases which are used today, but what adds a little bit of complication here are regulatory hurdles. Not in all countries phytases or feed enzymes in general are approved. And second, also, there is biological variation between fish species and between the environment we live in. And just to mention one point of concern, it is actually the presence or absence of seawater, of salt, because fish in seawater do actually drink, and that might interfere with the activity of enzymes, which are very sensitive to the ionic composition of the watery environment they are acting in, and also the stomach pH. And that stomach pH varies a lot between aquatic species. You have species without any stomach, which without any differentiated stomach, without hydrochloric acid secretion, where the whole digestive tract has a pH of around 7 or shot below 7. And then you have species like tilapia, for example, which have a stomach pH which decreases down to 2. And we have to keep in mind that phytases act in an acidic environment. So their activity is definitely very variable between species of fish. So this all can present hurdles for the application of phytases in aquatic species. So now I've been talking a little bit about the source of phosphorus, the bioavailability of phosphorus. Let's talk a bit about how much phosphorus do we add to the feed, without actually giving you numbers, because there are different views on how much phosphorus is needed. I would just like to talk about what is too much and what is the consequence of too much phosphorus. That's what we have to keep in mind. And second, also, what is too little and what happens if we have too little phosphorus? So first, what happens if there is too much phosphorus in the feed? Well, the first effect is definitely on the excretion of phosphorus. If there is an excess of dietary phosphorus, this will lead to an increased phosphorus discharge to the environment. An excess of dietary phosphorus will lead to also to a reduced digestibility of phosphorus, and the excretion of phosphorus into the water will increase. If this is left uncontrolled, which it is in most cases, because there is not an easy way of removing phosphate from the water, this will lead to eutrophication in the natural waters, and ultimately it will lead to ecological problems. Well, this has twofold consequences, or depending on your view on the system, it leads to two different problems. First, if you have a natural system where your water is from your fish farm is adding phosphate to a natural ecosystem, you can move it from, if you look at the graph at the bottom, from an aerobic system through eutrophication into an anaerobic system. So you can actually lead the system to an ecological collapse. This is because of an overproduction of biomass and consequently a lack of oxygen at the end, which leads to this anaerobic system. This is an ecological disaster, but we also find problems with the productivity of our aquaculture system. Many of today's aquaculture systems are closed systems. They are ponds. And in a pond, which is also exposed to sunlight, you easily find the same mechanism that you find in natural ponds. You find this eutrophic situation. If there is too much phosphorus excreted, together with the other nutrients like nitrogen and other trace elements, which at the end leads to a eutrophication of your shrimp pond or your carp pond, for example. So it's not only an environmental problem, but it is also a potential problem for the productivity. A second potential problem of too much phosphorus can also be in the fish. There is a very strong hypothesis that an excess dietary phosphorus leads to a problem in salmonids, which is called nephrocalcinosis. Well, normally an excess of dietary phosphorus will be excreted through feces, which is a mechanism that the fish has developed to protect the metabolism from excess phosphorus load. However, today it is hypothesized that an excess of dietary P will support the development of mineral deposits in the kidney of fish. Well, first, at a low stage, this is not damaging to the fish, but at a larger occurrence, it can actually lead to pathological problems in Atlantic salmon. And well, this could be caused by an excess of dietary phosphorus. The pictures are taken from a study which has looked at this connection, and you see the deposits in the tissue there, and they're actually very visible also when you open the fish. Now moving on to the other side of the balance, is there the chance of having too little phosphorus? And as nutritionists, of course, we know that this is the main thing that we are fighting against. We want to avoid a deficiency in phosphorus. So phosphorus in formulation is one of the first limiting nutrients in fish diets and also in shrimp diets. The requirement of the fish and the shrimp, especially of the fish, of course, is mainly for mineralization. Phosphorus is an essential component of hydroxyapatite, which is a essential part of the formation of bone. So it is the key of mineralization together with calcium. Calcium, as I mentioned in the first part of my presentation, is easily absorbed from water, so we will never have, I dare to say, never have a case of calcium deficiency, but we need to always balance the existing calcium supply from the water with the right amount of dietary phosphorus supply. And the second part is the energy transport, the ATP system, which is actually generating the cellular energy. In addition also, which I didn't write here, there's also a certain part of de novo synthesis of phospholipids, and the name tells you already there is phosphorus required for this. The main share of ingested phosphorus is used for the development of the skeleton. I don't dare to give you numbers of the percentage of this share, but it is definitely the main share. And also it is the first symptom actually of an undermineralized or a phosphorus deficient animal, that it actually shows errors, that it shows deviations in the type of mineralization of the skeleton. There have been lots of studies which looked at the mineralization of the skeleton in different types of fish. Fish do have exactly the same type of hydroxyapatite that we find in all vertebrate bones. So it's very well known. And there have been a series of studies from Professor Witten from Ghent University and his co-workers, who have in detail actually documented that a deficient phosphorus supply leads to very clear morphological changes in the bone structure, not only in the external bone structure, but also in the cellular bone structure. So this team has actually gone into the very depth of bone formation. And I'm trying to summarize in very few words, which is very difficult, the series of studies. But what they have found is actually that if a fish is fed a phosphorus deficient diet, very interestingly, the growth of the bone matrix, which is collagen based, continues. So there is no stop of the growth of the fish, of the animal itself. And actually the soft tissue, which is collagen, also continues to grow. But the embedding of minerals, the embedding of hydroxyapatite into this bone matrix is slowing down a lot. So there is a disbalance between the matrix growth and the mineralization of the matrix. Well, at first glance, this doesn't look critical because the fish continues to grow. However, what this leads to is an undermineralized bone. And such an undermineralized bone is more prone to damage when exposed to physical pressure or to any stress situation. So it is highly recommended. And well, I should say at the bottom here, you see also some graphs which are showing this undermineralization. On the left side, low phosphorus, regular phosphorus and high phosphorus groups, looking at the development of the vertebra. And at the right side, you see some graphs which show the pressure resistance of these bones. And less mineralized bones definitely are more prone to damages when being stressed. So in terms of bone mineralization, too little phosphorus can lead to structural problems in the fish, and finally, it might actually lead to bone deformations, which of course, at the end, presents a problem for fish welfare, for fish health, but also for product quality, because bone deformities are not accepted by the clients. So coming a little bit towards the end of my presentation, I would like to talk a bit about what is the future of phosphorus. I talked a bit about what is the role of phosphorus, but what can we expect in the future about phosphorus? Well, what we haven't talked about at all so far is the commercial value. It's the monetary value of phosphorus. Phosphorus is a nutrient which is extremely valuable in commercial terms, but also valuable in sustainability terms, because it is a limited nutrient, and within a few hundred years, which sounds a lot for us, but maybe not on a global scale or on a history scale, it is limited, and we need to work with it in a sustainable way. So we shall never add an overdose of phosphorus for different reasons. I've shown you one, which is eutrophication. And we should never add too little, because it can actually lead to problems in animal welfare and health. The development in aquafeeds today goes in a direction which demands more and more focus on phosphorus supply. We are producing aquafeeds with less and less fish meal. The use of land animal proteins, which are also a good phosphorus source, is different from market to market, from geography to geography, depending on legislation and consumer preferences. And this pushes the native dietary phosphorus towards a direction which is under the requirement of the fish. Since we are replacing all the animal proteins with plant proteins, and as mentioned before, the plant proteins consist or do have a phosphorus composition which doesn't favor bioavailability. So in the future, we will find more and more conditions where phosphorus is in a native state undersupplied in the diet. First of all, what we have to do, we need to have two actions which are related to this. The first is a full understanding of the bioavailability of phosphorus in raw materials, and even more important, its variation. We have done studies before which showed that the bioavailability of phosphorus in fish meals, for example, varies by plus minus 70, 80%. So there is a huge variability even within one source of raw material. And you need to have a possibility to manage this variability. And then you have to understand also how much phosphorus is needed. The phosphorus requirements of the animals at different life stages, which is extremely important, they need to be fully understood to not overdose and to not overdose during any given life stage. So that's one very important management tool. The other one is actually the use of the appropriate inorganic feed phosphates. As I mentioned before, they are a very consistent source of phosphorus in both in composition or concentration of phosphorus, but also in bioavailability. A given inorganic feed phosphate has one bioavailability. It has very little variation, actually, and thus it can be used in formulation with one value and no worries about batches that might deviate from that. So the last brick actually, which reaches the requirement and avoids oversupply of feed phosphate, is actually an inorganic feed phosphate of consistent quality, which at the end allows us to reach what everybody wants today, which is precision formulation. With this, I would like to end my presentation, and I would like to hand over to my colleague talking more about the specific details of inorganic feed phosphates. Thank you very much.
Cut off all your microphone, please.
Mm-hmm.
Thank you, Doctor, for your presentation. Now we will have the presentation of our aquaculture product manager, Guillaume Morin. Don't hesitate to ask all your questions in the Q&A chat room. So please, Guillaume, you can start.
Thank you, Justine, for this introduction, and thank you, Dr. Koppe, for this presentation of phosphorus in aquaculture. So me today, I will present you monosodium phosphate, or MSP, and how we can improve fish and shrimp nutrition. So first, to begin, so there are some challenges for sustainable aquaculture that Dr. Koppe presented, including provide efficiently phosphorus in aquafeeds, decrease discharges in water, and so reduce the environmental impact of aquaculture, and also health and welfare questions of animals for sustainable aquaculture. And so this aspect can be actually addressed with a highly digestible inorganic phosphate, such as monosodium phosphate. And so I will explain you how it can help to improve these aspects of aquaculture today. So in literature, there are a lot of studies showing that monosodium phosphate is a highly available phosphorus source for aquatic animals, including this study of Morales et al. In rainbow trout, showing that monosodium phosphate display digestibility reaching a 91%, which is 21% more than monocalcium phosphate, and it has a similar digestibility than monoammonium phosphate. In shrimp, we conducted a study with the University of Sao Paulo with wild lake shrimp, showing that MSP can reach 88% of digestibility, which is higher than monoammonium phosphate and monocalcium phosphate by around 9%. So this high digestibility allows to decrease discharges of phosphorus in water. So here in the study of Morales, they showed that in rainbow trout, the use of monosodium phosphate allows to decrease phosphorus discharges in water by more than 17% compared to monocalcium phosphate. And on the other hand, the use of monosodium phosphate allows to reduce the nitrogen discharges compared to monoammonium phosphate by more than 9%. And this can be easily explainable with the constitution of monoammonium phosphate, so which contain nitrogen. So to the excreted nitrogen from protein metabolism of fish, there will be extra nitrogen from MAP, which increase the total nitrogen loss. With the use of MSP, so you will not have this extra nitrogen, and so it will naturally decrease the total nitrogen loss of fish with similar performances from the MSP. So by decreasing phosphorus and nitrogen discharge in water, so on one end, it will help to reduce environmental impact of aquaculture by limiting eutrophication of surrounding waters and reduce the impact on aquatic ecosystems. And on the other hand, it's a very suitable phosphate for recirculating aquaculture system and closed ponds, which are closed systems. And it can improve, you can improve with it the biomass per cycle, because you will limit the discharge of phosphorus and nitrogen, which reduce the risk of nitrate peaks in the water, decrease thus the water change needs, and finally optimize the utilization of the facilities. So it was also shown that MSP could stimulate innate immunity in fish. So in a study of Hossein in rainbow trout, they observed that the use of MSP increase the lysozyme activity in rainbow trout blood compared to MCP and MAP. And so it's interesting because lysozyme, it's an enzyme secreted by immune cells in fish and shrimp that will attack the pathogen bacteria and kill it, and so contributing to the resistance to infectious disease. And they also shown that MSP can improve the immunoglobulin concentration in trout blood. And so with this, it can improve innate immune defenses of aquatic animals, and so reduce the risk of infection by opportunistic pathogens in animals, like, for example, Vibrio in shrimps. Finally, in this same study, they shown that feed the fish with MSP can increase the total the phosphorus levels of fish bones compared to MCP and MAP, so by more than 8%. And also interestingly, they showed that it also increased the calcium levels compared to MAP and monocalcium phosphate, even if MSP doesn't bring dietary calcium, such as monocalcium phosphate. So this can be explained by the fact that, as said Dr. Koppe, that calcium can be absorbed directly from water through the gills. And because MSP allow a better bioavailability of phosphate, there can be calcium will be used with phosphorus to form hydroxyapatite crystals, which is the main mineral component of bones. And so it will automatically, with more phosphorus available for bone mineralization, increase also the calcium levels. And so it's very interesting to limit the occurrence of bone deformities in fish. So to summarize the MSP benefits, so it has a higher P content and digestibility than monocalcium phosphate, which improves the phosphorus assimilation, so contributing to the precision formulation that Dr. Koppe talked about in his presentation. It also allows a better phosphorus and calcium bone mineralization than MCP and MAP. It decreases phosphorus discharges compared to MCP and nitrogen discharges compared to MAP, so preserving the water quality in closed systems and decreasing the environmental impact of open systems. And finally, it seems that it can also improve defense of innate immune system compared to MCP and MAP. And it is a mechanism, we are studying further the mechanisms that can give to MSP these beneficial effects. And so altogether, MSP improve animal performance and resistance and help to preserve water quality. Thank you for your attention.
Thank you, Guillaume, for your presentation. Thank you, both of you, for your informative presentation. Now we will start the question session. So don't hesitate again to ask all your questions in the Q&A chat room. I will start with one question for you, Doctor. In your opinion, even with high legislation in phytes that you explained before in aquafeed, do you think in the future we will have more and more phytes in aquafeed or not?
Definitely the phytase or general enzyme addition to aquafeeds will increase over time. The only bottleneck that I see at the moment is that we need a post-pelleting or post-extrusion application possibility for this. And this is just taking time. Factories need to be changed, they need to be equipped. And as soon as that is done, we will see the phytase. And it will be an integrated part of phosphorus management. We will have the native phosphorus, we will have the phytase released phosphorus, and we will have the mineral phytase, the inorganic feed phosphates, which will together form the total phosphorus supply of the animal.
Okay, thank you, Doctor. Question for Guillaume. How calcium levels in bone can be higher with MSP than MCP, since MCP provide also calcium?
So we have done some studies showing that actually calcium is absorbed from water. So when we did digestibility trials, we can see negative digestibility values for calcium. And so it's just because it's absorbed from water. And so because it's absorbed from water with more available phosphorus source such as MSP, so you will have more phosphorus available for the bone mineralization. And so with the absorption of calcium from the water, the fish can build hydroxyapatite crystals, and so contribute better to the bone mineralization. And after, there are some studies also in mammals showing that MSP can improve the activity of some enzymes involved in the bone mineralization. So it can be also mechanisms involved.
Okay, thank you. And again, about MSP, what are the effects of this product on growth performances and survival?
So it's something we are also studying. So we made a shrimp trial in Indonesia, and we observed that MSP can improve actually growth and survival of shrimps during the growth period. So it was more than increased by 2% for the survival of shrimps compared to monocalcium phosphate. And I don't remember well for growth, but it was more for the final body weight on a 90 days growth period. We obtain an increase of final body weight around 7.9% compared to monocalcium phosphate.
Okay, thank you. Do you have any questions? Yes, we have one. From a financial point of view, do you think it will be more interesting in the future to use phytases or phosphates?
I think actually it will be a mixture of both. And the simple reason for that is that we do not have an unlimited supply of phytate phosphorus. Phytate is only present in the diet at a certain amount, so you can only release that much of phosphorus from the phytate which is present. Everything that goes beyond in addition also, not 100% of the phytate phosphorus will be released. So there might always be one or two phosphate molecules which are sticking to the inositol ring and which are not bioavailable. So we will always have a gap there. So we have to fill the gap actually with the mineral phosphates.
Thank you, Doctor. I have a last question for you, Guillaume. What are the mechanisms improving immunity parameters?
Okay, so it's a good question. So in literature, for now, there are not a lot of elements. It could be because of the availability of phosphorus, but we observe increase compared to MAP that it's also really available. It has a similar availability compared to MSP. So it seems that it's other mechanisms, and so we are studying it to better understand how it works for immunity in fish and shrimp.
We have another question. Are there any studies presenting results on usable plant raw materials with less phytic acid, and which would make phosphorus available?
I think it is pretty universal that phosphorus from plants is in majority bound to phytic acid. So I'm actually not aware of any studies which have been done with raw materials which have originally a higher amount of available phosphorus. There are some there are some products which are processed soya products, for example, which have been exposed in the production process to phytase. So you don't add the phytase to the feed, but you add it during the raw material production process, or you let them go through a fermentative process. And that, of course, releases the phosphorus from the phytic acid. So these definitely have been tested, and it shows clearly that if a raw material has been pre-treated, the phosphorus becomes available.
Thank you. If there is just one more question, as research into necrosis with excess phosphorus in fish been tested on terrestrial species? I think it's for you.
Well, actually, I don't know. I'm a fish guy, and I don't know what has been done on terrestrial species with excess phosphorus and nephrocalcinosis. I must admit this.
Okay. I think it's good. So thank you everyone to attend this dissertation. We hope you find those presentation really informative and useful for you. So thanks again. Have a good day and see you maybe in the next webinar. Goodbye.